I will start with the introduction, though. This session is the Python data visualization. Kirstie Whitaker is the program lead for open tools, practices, research at the Turing Institute. Did I mess up your job title?
Yeah, it's about that.
And she's a neuroscientist and has done a lot of work in also in data science more broadly. I'll just mention oh man, I'm blanking on it now. The Turing Way, which is a book and community and just a lot of different things that she's led and is just like crossing a lot of domains. But she is also a neuroscientist. She is also ours. And she'll present data visualization today. Thank you, Kirstie. Take it away.
Yeah, thank you so much. And thank you everyone for coming along. I am very, very sad that I'm not having my wonderful 2-week sort of holiday, sort of fun, sort of hang out with my friends in the Pacific Northwest. I'm really glad to be back. The reason that it's so easy to kind of get tied up with my very long job title is that the program that I run at the Alan Turing Institute is called Tools, Practices and Systems, but I am low-key and not very secretively trying to change the title to Open Infrastructure, because I think that Tools, Practices and Systems is such a weirdly literal name for a program, and I think Open Infrastructure is just a much more exciting space to be in. And I'm really delighted to be able to give you this tutorial entirely on open infrastructure. So it's going to be using Python, Matplotlib, Seabourn, and we're going to run it all on the Jupyter Hub. The code is also available in the curriculum GitHub repository. It actually also has its own separate GitHub repository where I think the link is still in the README file, and that has a Binder link in there as well. So don't all go to Binder now, because the Alan Turing Institute, which is the UK's National Institute for Data Science and Artificial Intelligence, is actually part of the Binder Federation. And so it's 8 p.m. here in the UK, and my dear colleague, Sarah Gibson, is nurturing and taking care of our little Kubernetes hub that serves Binder around the world. And so if you all go there and crash it, you will slightly confuse her Tuesday evening. So you can do it all in the Jupyter Hub. So you can sort of log into your Jupyter Hub whilst you're listening to me now. As Ariel said, so I now focus very much on data science very broadly, but my background is in brain imaging. And the example that I am going to work through with the visualization is from a paper that I published a couple of years ago, three years ago now. And my great sort of passion is reproducibility, and that in terms of visualizations means making the exact same figure from your code and from the data itself, so that you don't have to sort of take your data, move it to another tool, change the colors, make it look good, line everything all up. You can actually make publication ready figures just from we're going to do it in a Jupyter notebook, but you could do it in a Python script or in RStudio, anything like that. I do want to say though that I start out with the tutorial very, very slow. It's very chill, and it will hopefully be very, very useful for you, anyone who wants to get used to sort of doing some simple scatter plots in Python. Towards the end, it sort of goes like whoosh, and it's really heavily starting to lean towards that like publication level figures. And so just take, all of you who are here, take what you want from the tutorial, take what's useful, and just don't worry about all the rest of it. So I hope you will enjoy it. I'm going to share my screen and go to my Firefox. Here we go. So I am logged into the NeuroHackademy hub, and this is my username. So you would, I think, see your own username here, and I'm in a Jupyter lab. And I'm going to navigate to the curriculum folder, and then it's Tuesday, and we are doing data visualization. So we're going to go into the Tuesday data visualization Whitaker folder. And there are 2 Jupyter notebooks here. Oh wait, I just want to delete this. That gets made at the end. There's a live code along one, and there's also one that you can just sort of run. So the data viz scatter one has basically all the answers in. I'm going to open this up now. And the data viz scatter live code one is the one that I'm going to hopefully live code through. So I'm going to go to this one. This is the data viz scatter, and I'm going to run all cells, and hopefully that's going to happily go through the entire tutorial. And then if I find that I need to go back and sort of remind myself what the command was or what I'm supposed to be live coding with you, I'll be able to do that. But let me collapse this down and open up data viz scatter live code. I'm also going to make this full screen, which I think is good. And I'm just going to make myself smaller. So if I start looking really strange, you know, put some messages in the Q&A. Chat isn't on, so I can't like get messages from you. So if there are any problems, please put it in the Q&A. I'll be able to see that. Or message Ariel on Slack, and he'll interrupt me. Okay, so data visualization with Matplotlib, scatter plots. And just to be really clear, there's a lot of stuff that I cover that is generalizable beyond scatter plots, but I think it's helpful to be able to do something simple but really well. So Michael Vendetti and I published a paper on neuroscientific insights into the development of analogical reasoning. You can go check out the code and the process data at that GitHub repository. And we're going to recreate figure 2, which is this one right here. And I've already made this point about the philosophy of like, take what you need. It's available. You'll be able to come back to it. You can ask me any questions. Just feel free to ping me in the Slack channel, and I'll happily answer anything that you, any questions that you have. And the first thing that we're going to do is import some modules. So if you haven't used Python before, then this might look a little bit unusual. But if you have used Python, then you'll have seen something like this. That's bringing in different packages that we're going to use. There's a few from Matplotlib. There's a nice little IPython one. There's NumPy, the operating system, Pandas, which is going to allow us to manipulate the data. Stats models, where we're going to fit a curve at some point to the data. Seabourn, and then string is going to allow me to format some text nicely. So let me run on that. So click. So the little star over here means that it's currently running, and the 1 means that it's done. Cool. I'm going to very briefly, let me just check my time over here. I'm going to very briefly tell you about this study so that you know what we're plotting. Otherwise, it just seems like a little bit kind of hello world as a tutorial and not very easy to engage with. So I spent my PhD at UC Berkeley asking 200 children and adolescents to line an MRI scanner. And they had to, there were 2 different types of questions. So analogy questions, which is this one on the left, said, which of the picture along the bottom which of the pictures at the bottom goes best with the 3rd picture in the same way that the top 2 pictures go together? So in this case, a dress lives in a wardrobe and milk lives in the fridge. So the correct answer down here is the fridge. So that's an analogy question. A semantic question said which of the pictures along the bottom goes best with the picture on the top. And so here a pen writes with paper, and the perceptual lure is one that looks kind of similar, but is not actually semantically related. Thanks, Cooper. That is really helpful. So yes, thank you for helping everyone else install Seabourn. That's great. So we have analogy questions where there is a correct choice, a semantic lure where milk goes with cow very much, but it doesn't fit the analogy, a perceptual lure where these 2 images look kind of similar, and something that is absolutely completely unrelated. So that's going to come back later on, and you can always scroll back up to the top if you need to remind yourself of the task, the analogy questions and the semantic questions in an fMRI task. And we're just looking at the behavior in this. There's no brain related. So our hypothesis is that accuracy on both tasks will increase at a decreasing rate with age. So that means that you get better, you get more accurate as you get older, but those changes will be smaller, between sort of 17, 18, 19 years old, there won't be that much of a difference. And accuracy will be higher for the semantic task compared to the analogy task. So the semantic task is easier, so that's not surprising. Well, these are our hypotheses. We think that reaction time will decrease at a decreasing rate with age, and that so you'll get faster, so you get more accurate and you get faster as you get older, and that reaction time will be smaller, you'll be faster for the easier task than the harder task. We also hypothesize, and this is actually a more interesting part, I think, that there will be more semantic errors than perceptual errors, and more perceptual errors than unrelated errors across all ages, although the number of errors will decrease with age, which corresponds to an increase in accuracy. Now, those are our hypotheses. That's the question that we're making some visualizations and we'll do some statistics to look into. But I want to just make a really strong point here, which is that we can visualize them, but we can't statistically test by making the visualization. So the visualization will be able to help us understand what's going on. But as I've written down here, just because a line looks like it's going up and down doesn't mean that it's statistically significantly doing so. You can tell many stories with a picture, including ones that mislead people very easily. So with your great power of making beautiful and compelling plots in Python, you should also be very careful with your responsibility of communicating that in an appropriate way. The data is in this CSV file inside the GitHub repository, but I've made a copy of it. So let me just pull back the folder. So inside of the data folder, there is a CSV file and it looks like this. So there's a subject, there's the time point that they came in for the study, there's sub-ID long, sub-ID short. It's just the different ways in which we stored their information. We have a column about whether they're male or female, so 0 if they're female, 1 if they're male. Their age at the time of scan, the number of, so R1 is a one relational, which is the semantic task, the easier task. The number that they got correct, there were no semantic laws in there, the number of perceptual laws, the number of distractor laws, which are the unrelated, the number of responses that they had. Sometimes they stop the scan partway through because they're kids, and the number that they omitted, so the total number of questions here. And then we've also got some information. I'm feeling like I don't want to need to go all the way through this, but we've got percentage accuracy, the number of errors including omitted, the number of errors excluding omitted, and various other sort of derived measures coming along over here. And there's lots of these. And then if I chug along, we'll get to the reaction times for each of the different types of questions. And we'll get to R2, which are the analogy questions. Feel free to ask me probably afterwards if there are specific questions that are not very clear about the data. Let me close that down. So these are our important columns. And I have said all of this. So I didn't want to live code this because this is the sort of stuff that I'll make typos on an awful lot. But we're going to read in the data into a Pandas data frame. We're going to have a look at it. We're going to look at all of the columns. And then we're going to only keep the particular columns that we want to look at. That's just going to make it easier for us to have a look. And we're also going to just describe some summary statistics. So let me run this cell. Here you go. So those are the first 5 rows. These are all of the columns. We already saw that because I took you through the CSV file. And here's some summary statistics. So we have 138 participants in there. They have a mean age of 11. The youngest is 6 and the oldest is nearly 19. And you've got all of their various data on here. So first things first, let's start by making a scatter plot with age on the x-axis and semantic accuracy on the y-axis. PLT dot scatter age scan. Yeah. Now what's semantic accuracy? That will be R1. Percent accuracy. I did it. Look at me. So PLT is how we imported Matplotlib. We're doing a scatter plot, and we've just put in the X values and the Y values, and here we go. So what about accuracy on the analogy task? So that's going to be plt.scatter. Data frame, we're going to get the age column from on the x-axis, R2, percentage, accuracy. I'm pressing tab, by the way, to get those different options. That's an autocomplete. So when I press tab, that's when it gives me the different possibilities to complete the variable name. And those are my values for the harder one, the analogy question. That's nice, but it'd be more useful if we put these two on the same plot. So watch this. We're going to just take this line. I'm going to copy and paste, copy it. I've done it with the keyboard shortcut and paste. And then I'm going to get this line, copy and paste. So one scatter plot with the semantic, one scatter plot with the analogy. And there they go. They're both on there. How cool. So I've written down here, that's very clever. It doesn't make two different plots because it assumed that I would want these two plots in the same axis because they're in the same cell. And if I'd called plot show in between, then I would have ended up with two plots. So let me just show you that. If I copy and paste the exact thing that I had before, and I say plt show, show, and I run that cell, now I have my two plots back because I've told Matplotlib that I want to see that scatter plot, and we'll make another one. So the scatter plot above shows how easy it is to plot some data. And this is good, right? This is totally fine. You have now explored this data. But there might be times when you want to have a little bit more control over how it looks. This is kind of an important little section here, which is that Matplotlib object-oriented architecture is pretty intense. And I don't think you need to know how Matplotlib works to be able to use it. So my message to you is to say that you need to know that a figure is a figure. It's the canvas on which you'll make your beautiful visualization, and that it can contain multiple axes displaying different aspects or types of data. And it makes it easier. There's a nice subplots command that's going to create a figure in an axis altogether. So if I say plt subplots to show you that, I've made an empty axis which takes up the whole figure area. Here you go, figure and axis. So let's add our plots to a figure. So we're going to say fig ax equals subplots, and then ax scatter. Wait, let's go and get my command up here. So when I run plot subplots, it returns both a figure and an axis. And now instead of telling Matplotlib to just generically plot, I've told it specifically to make this plot on the axis that I've defined. And there it is. And that's because we're being more specific about where we want to put it. Oh, and then I didn't have to, but I was supposed to say plot show at the end. And that just makes it, as you saw from my live coding, you don't need it, but it's sort of good practice, because otherwise you can either get into a situation where you've got tons and tons of plots that exist but aren't shown to you, and then at some point you type plot show and there are just 100 different windows that pop up in front of you with your various different plots that you didn't realize you were making, or you sort of are relying on the defaults for Matplotlib to guess when you want to show your plots. And so it's just like a nice sort of behavior to say plot show when you want to see it. So in the paper, I modeled the data with a quadratic. And I think probably if I was doing the analysis again now, I probably wouldn't use a quadratic, but I did. So we're going to add a column to the data frame for the age scan, for a squared column. And then I'm using stats models here to come up with a formula where I'm going to say that I think the accuracy on the semantic task is a function of the square of age and a linear term for age. Then I run that model. So my model for the semantic is an ordinary least squares with that formula and my data. I'm going to fit the model, and that's going to give me my results. And then I'm going to print out a summary of the results. I'm going to predict the values. So for each X value, for each age measure, I'm going to get the expected value from my model. So the predicted value that's going to lie on that quadratic line that will fit through the data. I'm going to print those out. And then I'm going to do the same thing here. So what we'll see when we print this out is a summary of the model fit for the semantic task with percentage accuracy, and also the values for each of those 138 people. And we're going to see a summary for the analogy task and the predicted values. So let me run that cell. So those are our regression results. It's got a really high R-squared, very, very significant. And these are all of our values. So these are all of the predicted accuracies for each of the different people for the easy task, for the semantic task. And here we have an even higher R-squared. It's got a much stronger effect with age. That's actually because this one is kind of at ceiling. It's not doing a huge amount. And then we've also got all of the different the accuracies for the analogy task. So let's plot that modeled pattern on our scatter plot. So I'm going to scroll back up and grab this. So this is what I wrote before. I'm going to pull it all the way back down here. Okay. And so we've done the real data. And then we want to show the predicted values. Oh, wait, sorry. We want to show the predicted values, which are called predicted SEM. Predicted SEM. And predictive Anna, like this. There we go. Okay. So now we said, okay, it looks good, but we do usually draw them as a line rather than as individual points, and they'd be the same color. Okay, so let's copy and paste this, and let's use plot instead of scatter. Plot. And yeah, you could see from my notes that was going to be not okay. So what's happened here is that we've connected everybody just in order that they were added to the study, and that doesn't make a nice plot at all. We forgot to sort the data into ascending order before we plotted it. So we're going to add those predicted values to the data frame and sort the data before we plot it. So these were my predicted values from the model for the easy task. These were my predicted values for the model from the hard task. I'm going to save them into the data frame with this underscore pred, which stands for predicted. And then I'm going to sort the values by age so that my data frame is sorted by age. So let me run this, and actually I could even add a little thing in here and say DF. And so now you can see we've got the index has remained, but it's all shuffled around because now all of our subjects are in order. So hopefully now that everyone's in order, the lines will connect up in a much more sensible way. So let's do that now. So that was just to copy and paste the exact same code as before. Yeah, I did this last night. That is not what I'm supposed to do because I put in the values, not the data frame answers. So let me get the values from the data frame and put underscore pred at the end here, and this one, and put underscore pred. And there you go. Okay, cool. So now we have some scatter plots and we have some lines going through them, scatter plots and some lines going through them. And I think these are too skinny malinky, these lines, and so I'm going to copy and paste here. And I'm going to make the lines a little bit thicker. And I have to say I've forgotten what the command is for line width. So I've clicked on, let me just show you this actually, I learned this from Tal at NeuroHackademy, I think 2 years ago, and I'm very proud of it. It's very useful, well, not proud of it, but it's useful every day. If I press Shift and Tab with my mouse over the command, I get the help file, the help the doc string up here. So I can just scroll through here and I say, right, line width, all one word. I'm gonna add comma, line width equals 5. Do you remember that from when I practiced last night? Line width equals 5. And there you go, that's just a little bit of a nicer plot, right? We've got slightly more sort of visible lines going on here. But they're not labeled. So, you know, I've told you that this one's easier and this one's harder, but that's not going to help the readers of the paper. And so let's add a legend. Okay, so I'm going to get these our code. We're just going to keep building this up, just building it up each time. And the function is called ax.legend. And it needs to know, it will look for plots or scatter plots that have labels. So let's add a label. So label here equals semantic. Oops. And this one is label analogy. This. And I can add in ax legend. And so now we have the semantic line, the blue dots has been labeled, and the analogy results from those trials have been labeled as well in our legend. And Matplotlib hasn't added the regression lines because they don't have labels. So I didn't give this one a label, and that's why it doesn't appear in the legend. I've linked to the documentation, and it's got a lot of, I'm not going to click on it actually because I don't want to sort of navigate away from all of this. It gives you lots of different options for where you can put that legend box. So if I copy and paste here, I can say lock equals center, and that puts my legend right in the very center. I don't feel like that's the most useful spot to put it in. I could say upper left. It puts it up there. It's kind of cool because the defaults now have it as like transparent. So it's cool that it's up there, but it's obviously a silly place to put it. So lock equals lower right is clearly the best place to put it. And that was the best place. So if I leave it as default, it will figure out where the fewest data points are and put it in that place. Now, I'm going to take a breath actually before I go. And I don't see anything in the Q&A, so I'm going to hope that that means that everyone is doing okay, and I'm not just talking into a disconnected internet. So I don't mind the blue and orange colors, but I don't like them, right? So at the moment, Matplotlib is coloring the first scatter plot with its first default color and the second with its second default color. And when we give it a different type of plot, it starts the color cycle again. And then, so if we move the order of the regression lines, the colors will change. So let me sort of show you that behavior, because I could have, when I was writing this code, I could have done the two scatter plots first, and then done the two line plots. And that actually would have been totally fine. But if I had decided to do, if I decided to do, I don't know what happened here. I'll just go over to the side. If I decided to put the analogy task first and then the semantic task and run it, now they've flipped. And that's because it's just Matplotlib doesn't know that this variable is related to this variable and that I want these two lines, that these two lines mean something to each other. It's just being like, look, I've plotted the first one first, the second one second. I use the first color for this one, the second color for this one. Same with this. So it's actually easier to explicitly set the colors. So let me copy and paste, and I can add, in fact, I'm going to hover over here again and find the color. I think it's going to be C. So C equals red, just to go like, just super traditional and boring. Red and blue, and we've still got this one is still blue because we've got the R2 here. This is the analogy task, and we'll make this one red. So now I've got red, blue, blue, red, no problem, that's totally fine. And they're back to being aligned with each other. Now, I also think that these red and blue are like wildly offensive to the eyes. And so I would like to introduce color management with Seabourn. So Seabourn is a Python data visualization library that does really nice high-level interface. So I want to just take a moment because a lot of the things that I'm doing right now in Matplotlib, Seabourn can do much faster. And actually, further on down in this tutorial, we are going to sort of replace everything that we're doing with Seabourn. My experience of learning how to make visualizations in Python was that a lot of times the examples were very, very clever and they made beautiful pictures with just one line, but I found them really difficult to adjust because I didn't really know what was going on underneath. So I hope that by sort of building up, line by line, each of these different points, making it just a little bit easier for you to kind of deconstruct some of the really clever examples that you'll find and be able to tweak them as you need. So you can either build up, which is not what I recommend, but at least if you build up, you learn how some of these things work and that will help you later on. That's my philosophy. You can take whichever ones you want. Okay, so it does many beautiful things, and that's my point that I just made here. One of the very nice things that Seabourn does is it manages colors really nicely. And so I used the red and blue that were in the published figure for this paper, came from the Set 1 Brewer color map. Now, there's a link there, you can click on it to go and find out a little bit more about that color map. And what this piece of code here is doing is saying from the Seabourn color palette function, get the Set 1 color map and specifically pick 5 of the colors from it. And we're just going to print the color and then use an inbuilt command called palplot, which is a palette plot, which is going to then show us those colors. So if I run that, I did shift and enter to run the cell. These are my RGB values for the different colors. So my red has a lot of red, my blue has a lot of blue, my green has quite a lot of green, although it's a little bit of a mix. So I've got 5 colors here, and that's saved really nicely into a color list. So for the first entry in the color list is this tuple of 3 numbers. So now that we have much nicer colors, let's change the red and the blue in our accuracy plot. So we're actually going to keep the numbers we're going to keep them as red and blue, but we're going to make them this red and this blue, which is going to look so much more beautiful than this red and this blue. So copy and paste here, and instead of C being red, we're going to call it color list entry 0, which is the first entry. Color list 1. And actually, this is sort of, it's going to confuse me, so I'm just going to move these around. So now we've got accuracy, we've got semantic and analogy here. I can see there's a question, by the way. I'm going to come to that in just 1 second. I'm going to grab my first entry and my second entry in the color list. Let's go. Oh, okay. Let's just, it says it wants color, so let's try that. That's better. Okay, it doesn't want C anymore, it wants color. And now we have red and blue lines that are just way less offensive to the eyes. Let me look at this. Could you apply hexadecimal color codes through Seabourn? I don't know that off the top of my head, but oh, someone's answered it for me. Yes, so super. I'm not surprised that that's the case. Thank you so much to my beautiful assistant, Ariel. So we got some nice color, but Seabourn is not just your beautiful color. So it also has some really lovely aesthetics. And I really encourage you to have a play around with them, because it's the aesthetics that really take you from sort of screwing around and making some okay plots that allow you to understand your data to really being able to beautifully communicate your data. So we're going to check out the poster context with the dark grid background, and set context, poster. I can't remember, I'm going to have to look it up, I'm so sorry. Set style. Right, let me go grab this from my cheat sheet over here. So we set the context, we want it to be in poster context with a font scale of 1, and set style as dark grid. So I'll run that, and then we'll run the code above that remakes the scatter plot. So let's copy and paste. And yikes-a-rama, that is not a great plot. Now there's another style that's called notebook, and let's try a ticks background. So I'm going to grab these two up here. And instead of poster, we'll say notebook. And instead of dark grid, we'll say ticks. Our code again. And run it. And that's much nicer. And you can see these ticks sticking out. That's what makes it the ticks style. I'll just quickly scroll up to the default style, which is also ticks. So that's what you're looking at there. The setter, we've got back to the Matplotlib default. The settings have changed slightly since I wrote the original code in 2016, but I think the closest setting is a notebook context with a font scale of 1.5 and the white style. So those are my favorites that I particularly like. So the font scale goes up just a little bit. Keep it in notebook context. I'm going to say white. And copy and paste. And now we have, I think it looks nice, right? Like the font is a little bit bigger. It's just sort of a little bit easier to see, and I like not having the ticks. I don't think they're necessary. When you run the set context and set style commands, they become global settings. So usually I just put them at the top, because one of the problems with Jupyter Notebooks is that it remembers lots of stuff. So if you go jumping around in a different order, then you can get a little bit confused about where things came from. So I personally set the context and set the style at the beginning of my Jupyter Notebooks, or in the function where I'm plotting them. And it's easier to just do it once. You definitely, you can do it on an individual basis, but I personally can often get kind of confused about whether it's going to persist or not. So I just like doing it once and keeping it there. And I also like the plots de-spined. So let's just add in the spined option. So I'm going to put this right at the end and say SNS de-spine. And there you go. So that's just got rid of this top and right box, which I think again looks a little bit cleaner and a little bit nicer. Okay, I'm going to take a drink and we're going to keep going. So now we're getting to a point where either you want to start automating lots of plots, like if you have a bunch of different variables, you might want to put the axis labels in for all of them, so you can just sort of loop over a bunch of different variables, or you actually want to publish the plot, you should label your axes. That's like visualization 101. How will anyone know what we're looking at? So let's label them. So copy. I'm going to keep this style, by the way, because I like it. So we've got a label here. We've got a color. Oh, sorry, we're not going to do it on top. We're going to do it on the axes. And that is going to be, here we go. This is, honestly, this is like probably the thing that I Google the most, is how to set X and Y labels all the time. So it's pretty easy. Once you Google it, it's get your axis and set the X label to be some string. I'm going to say age and years. and set the Y label to be accuracy, which is our percentage response. I'm just going to delete this because I'm going to copy and paste my code over and over again. So let's run this. And now we have some nice labels on our axes. How beautiful, super easy. One of the things that's really nice to do is be able to set the minimum and maximum values for a figure. So Matplotlib is actually really good at guessing the good places to start and stop, and it's doing a really good job. But one of the things that I really like to do, particularly when I'm like automating, making figures, is automating like adding on different subsets of the data. And if you find that, so maybe I want to look at just the girls or just the boys in this data, the problem is that if a couple of your extreme values, like this one here, let's say that this is a boy, if when I make the plot for just the girls, when Matplotlib tries to find the minimum value, it's going to find a much higher value. And it means that these axes are going to be just ever so slightly different. And that is maybe a little bit sort of bad science in terms of presenting two plots that look slightly different to each other. But it just makes me so sad as a sort of pedantic human being that I'm not able to line everything up perfectly. So we can see what it's guessing. So sorry, I'm going to go and grab my sample here. Here we go. Okay. So this, again, I'm so sorry for not being able to remember that. I didn't quite have it in me to try and figure it all out whilst you were all watching me. So this is going to print out the X limits from the plot that has already been made and the Y limits from the plot that's already been made. And the minimum value is going to go first and the maximum value is going to go second. So min max is guessing 5.5 and 19.5 and 10.75 and 104. And those are, you can't have an accuracy of 104, but that's okay. You know, it doesn't know that. And it's doing a really good job. And so you could leave it, but there are sometimes times where it's really nice to actually not leave it to guessing and really sort of define. And so I wrote a little function to pad the axes by 5% of the data range. So that's going to get the maximum value of the data, the minimum value of the data that gets passed to this function, and remove 5% in this case, because the default is 5 of the range, make that the new minimum, and add 5% of the range and put it on top, and that's going to give us those. So now if I in here, I can say ax so I knew it was that, right? Ax set x lim So my x min, x max are going to be the min and max of h. And my y min, y max is going to be the we'll actually do the range on the harder one, because that is going to give us that. I know that that's got a larger range. So x set x lim, x min, x max, set y lim, y min, y max Upset about, oh yes, I forgot to put my square bracket in here. And here we go. And so that has now like actually set specific a little 5% of padding around the outside. You can't really tell the difference. If I made the pad percentage 25, we should probably see a bigger difference. So we've got a lot more white space all around the outside. And I wanted to show you that if you set the pad percentage to 0, so if you just plot with the range itself, which seems like a sensible idea, it actually looks super ugly because the dots are not, in fact, infinitesimally small. They have size, and so when you plot to the range, you lose a lot of the dots at the extremes. So you lose them up here and down here as well. So I think my message said you shouldn't do that. Seabourn and Matplotlib also make a good guess about where to put the X and Y ticks, but they're not where I would put them if I was drawing a 6 to 18-year-old age range. So like 7.5, 12.5, 17.5 are not like, they're not really sort of the ages that you think of when you think of a 6 to 18-year-old age range. So I think we should just put the ticks where I think these are where the ticks should be, at the minimum, at the maximum-ish, and at some spaces in between. So let me grab our code. And these are, well, let's set the pad percentage back to 5. Let's just add a little comment. The X and Y, and now here we're going to I gotta go steal it again, I'm so sorry. So set the X tick locations is X, set X ticks. It's really easy. It's just really hard to remember. And we're literally just going to tell it in a list to put a tick location at 6, 10, 14, and 18. And there you go. Doesn't that look nicer? That looks cleaner. It looks much more meaningful. For the Y ticks, we can use the ticker locator params to put them in the best place. So actually, accuracy, accuracy, I think we just want to sort of put them in a sensible place. Put them in the best place for getting a maximum of 6 ticks. This is basically what Matplotlib is already doing. I'll show you the command. So let me copy and paste. And set the Y tick locations, which is going to be X, set Y ticks. And this is, here we go, take it back. So we're not going to set the Y ticks because we're actually going to ask it to look at the axis, look what's already plotted on the axis. We're specifically asking it to look at the Y-axis here. And we're going to tell it that it can have a maximum of 4 sensibly spaced bins. So if I run that, again, it's actually done a really nice job, right? We've got 25, 50, 75, 100. Perfect. That's pretty much what you would want to see. And if I copy and paste this, if I put this in as 6, what's kind of cool is that it doesn't give me 6. It actually gives me 5 because it sort of knows that trying to divide 100 by 6 is going to give me some weird values. So it's actually pretty clever about being able to say, I know you want a maximum of 6, but we really think 5 is the best one for you here. And the important thing to remember, this is why I had to go and copy and paste these because I never remember the commands properly. There's a difference between the X and Y axis limits. So that's like this endpoint here, this endpoint here, this one, and up at the top, and the tick locations. So 18 is a good example here. 18 is not at the maximum. And so you can control the difference between these 2 points. Let's take a minute. So that is pretty good with Matplotlib. It's really nice. I think it's a really beautiful picture. But Seabourn actually can do all of this all in one go. So let me grab all this, put it in here, and we're going to replace the scatter and plot functions with a reg plot function. So I'm going to say SNS reg plot, page correlating with the semantic accuracy, same color, and I want it on this axis. And then I'm going to copy and paste that and put in the analogy measures, the other one, both on this axis as well. So let me run that. And fine, the plot looks okay, except for the fact that this like linear best fit line is definitely not the correct choice. So I can copy and paste, and I can put in, I'm just going to put in some new lines on here so you can kind of see a little bit more about what the different options are. If I tell regplot to do order equals 2, I'm now telling it to do a quadratic fit. If I run that cell, there you go. That's looking really nice. The advanced legending, I will do, but I'll do kind of quickly. So this is me now we're getting into like the real sort of twiddly sort of spaces. So I really don't like the fact that the legend shows a dot. I think the legend should show a line, but the data that I'm plotting the label is actually the dots. So I go back and forth about what I want to look here, and I want it to be, the line. Sorry, I've just realized we've got rid of the separate plots, these two, right? So now we're only passing the data, and internally Seabourn is giving me the horizontal, the line that goes through the best fits that shows me the predicted values. So it's difficult to replace this with a line. Like a line I think would look better as part of the figure. So this is just a little function that does that. I'm basically 100% sure that I copied and pasted it from the legend guide or from a Stack Overflow. That's how I learn how to do everything. And so I'm going to just copy and paste this. I'm going to run my function that already exists there. I'm going to copy there. And after I've added the legend, I'm going to add line to legend for this axis, for this color list, for my my label list. And we'll put it in the best location, no problem. Let's get rid of this guy, we don't need him anymore. And now we have a line instead of a dot in that. And I just think it looks much, much nicer. So I got rid of this, I commented it out. I can just show you that if I delete it, it's there. So that's our nice figure. And it looks really similar to this one, right? Like it's slightly different sizes, but it looks really, really similar. Except that the published one has these other plots in here as well. So we can actually do a second plot, and this is where, oh my God, this is where the beauty comes in, because now I can copy and paste all of this in. I can change this from R1 percentage accuracy to R1 core, no, mean RT core. The core, the core is corrected because we dropped some outlier values, and then core is correct for the answers that they got correct. We can put in the reaction time for the semantic trials, the reaction time for the analogy trials. We'll get the min and max for the harder trials because they'll have a bigger range on them. The age can stay the same. These locator params for the Y-ticks will be automatically calculated. We'll update the label to say mean RT seconds. And there's our plot. How cool is that? It's so beautiful. And we can make, again, very quickly, the error plot. Control C, Control V. And in this case now, we're going to say the three errors are all associated with the more complex, the harder task, which is the analogy task. And I just want to scroll up. Are we plotting the reaction time or the analogy error rate, the percentage response? So R2 percent distractor. And we'll do different colors for this one. So we'll do the second color. R2 distractor, perceptual. And we need a third line on here because there's three different types of errors. And semantic error. Fourth color here. And we can get, let's do, this one has the largest variance. We'll put this one in here. And my, we'll do distractor. Perceptual neural and the semantic, all in colors 2, 3, and 4. Oh my goodness, it worked. Magic. And so now we've just by sort of copying and pasting, reusing a lot of the code that we already had, particularly reusing the code for laying everything out, we now have some nice plots. Now I'm pretty confident that actually I did those in the wrong order. So I should have done semantic, perceptual, and unrelated. But anyway, you get the point. I could move that around in various different ways. What's going on here? Right, this is one function to plot them all. So we're building up, we're building up. I've actually already written a really nice function that does essentially all of the different things, but loops over the behavioral measures that I want to plot, sets the tick locations, sets all of these various different ones, figures out the color. So there's my function. And I can make the three different subplots. I can make the three different plots all in one go. So let me, I've got 1, 2, 3 different plots. That's what we've made. This is one that I've created earlier. And we want to put these 3 plots into one figure. So we can use subplots to set the number of equally sized plots and fig size to set the dimensions of the figure. And I am so sorry that I cannot remember the dimensions. So here we go. So now instead of getting just an axis, I'm actually going to get 3 axes back, and they're going to be in the form of a list. They're going to be in one row, but 3 columns. And this is the size that I've sort of previously figured out is like a pretty good dimension. That's what they look like when they're totally empty. I'm going to make my figures directory just so that I'm ready for it. And I can for my figure, my ax list at the beginning. My axis for the accuracy is the first entry. My axis for the reaction time is going to be the second entry. And my axis for the third one is going to be the third entry. And I'm going to plot, I'm going to show that. She hopes. And there are my plots. How lovely is that? So all in one go, and I can save it by copy and paste this. And if I leave plot show there, but I do big, save big, and call it, whoops, figures, figure2.png. I will save it, and if I head over to my folder, into the figures folder, there is now a PNG file that is the one that we've just made. Isn't it beautiful? Oh, it's been cut off. Ah, nightmare. So we're going to add yeah. Oh yeah, wait. I didn't tell you about plot type layout. Type layout is really nice. It gets rid of all of the white space and sort of figures out a sensible amount. And I've also previously figured out that having dots per inch of 150 is pretty good, and having like no additional padding after I've done type layout does it really nicely as well. So let me get rid of this one and run it. And this was created a minute ago, but it should update to seconds ago. If I open this up, well, it's really big, and I now have much sharper fonts, and it's much cleaner. So it looks really good. I love it. I'm definitely going overboard on panel labels, and I'm also out of time. But this is like really me being unbelievably pedantic. You could definitely, the fastest thing to do is definitely to just go into Photoshop and like put some numbers or, you know, letters A, B, and C on your panels. But I've written a little piece of code here that uses axis.text to put in some text at a particular location at X and Y coordinates, as I figured out previously. And if I run these two, adding in the panel list, apparently we don't have Arial involved, but we do have Deja Vu Sounds. And now we have A, B, and C as the panel locations there. We did it. That's the one that let me show you in the markdown. That's the one from the GitHub repository. This is the one that we've just made. And they look, well, this one looks somewhat beautiful, a little bit cut off. Okay, I hope that was useful. Let me just look at these Q&As and see if there's anything that I can help with. Is there a way to assign each of the figure objects to a variable in the workspace and then call them later as subplots? So I don't think you can have a figure inside of a subplot, but you can definitely have an axis inside of an axis. So the subplots are axes inside of a canvas, which is the figure. So I would think more about having axes inside of axes, and then you absolutely can do that. And you can definitely assign axes to variables as well, and you can loop over them in various different ways. Can I change the transparency of the lines or the confidence intervals? Yes. Yes to both. Yes to both. The way to change the confidence intervals will be with a Seabourn option. So let me share my screen again. Unless, Ariel, do you want to interrupt me? Is it okay if I take 5 minutes to answer questions? Or
please do.
Okay, cool. Come on, yeah. Loiter over me and tell me I'm sticking around too long. Let's go back up to one of the. Sure, let's do here. Okay, so if I hover over reg plots and do that, add that shift tab again, the CI option here is 95. And so that will allow me to change the confidence intervals. And then I also think that you will be able to, Ariel, can you tell me if you can see me Googling here?
Yeah, I can see you Googling. I'm just going to say, I think the question was about the transparency of those intervals.
Oh, okay. Oh, sorry. Right. Oh, I thought it was like a, okay. Yeah. Well, now you're finding out.
But yeah, you can also show how to change the size of these. also
You should know that you can have confidence intervals, standard deviations, integers, or none. But yes, changing the transparency, that to me is one of those things that I feel like is probably harder. This is where like you have to sort of hack
I wonder
Seabourn.
if alpha works there.
Do you know how to do it?
Maybe the alpha keyword. Try alpha equals 0.5. Let's see what happens.
But how would you pass it as a, can you do it?
Right, it's a very plot. Yeah, I don't know.
So I think this is the problem. You have to like.
This will affect the line.
This affects, yeah. So this is where it sort of becomes a little bit harder. But if I go up to these ones where I was doing things much more easily, now I think I could add in alpha. Let's try that. And can you see that now I've made it lighter? So this is like a good example of where it's much easier to do if you're just building everything up element by element. So I could make this rather than if you're sort of using the Seabourn one. But I would say that if you ask that question in the NeuroHackademy Slack, I am 100% confident that somebody watching this knows how to do it and knows how to do it better than me, and they would be able to answer that question. So the answer is like yes, but it's a little bit difficult, and the alpha keyword is your friend. Does Seabourn work together with Matplotlib? Does it have special functions to make it bigger? Yes, that's exactly right. So Seabourn sits on top of Matplotlib. So there is no question of like, do you like Matplotlib or do you like Seabourn? Because Seabourn is a wrapper over Matplotlib that actually has just a lot of statistics functions in there, and then is sort of set up to try and make it easier for you. But Seabourn and Matplotlib are best of friends. This is the gallery for Seabourn. You can make some beautiful violin plots, and I think these like these hexagonal plots are kind of nice. You've got various heat maps and things like that. They're all sitting on top of Matplotlib, and Seabourn in the background is calling Matplotlib. Do you share the final version of the script? Yep, so the final version of the script is in the one that is not live coded. So it's in Jupyter Hub already, it's in the hub. It's also in the GitHub curriculum repository. And this is the one that I've been using, which is the one that has _live code. So that's got these sort of like blanks where the answers were. But the dataviz _scatter, that was the one that I kept going back to go and cheat because I couldn't remember the commands, and that one is all complete. So you'll be able to use that, and that's available in GitHub and also on here. I think that's all of the questions.
Yeah, I think you've answered all these questions, and we can, I think, thank you so much, Kirstie. That was great.
Well, I think I'm going to go and just, it's 9:10 here. So I'm going to go like melt on the couch for a little bit. But and I will have my Jupyter Lab still open. So if anyone wants to ask me questions, I'm really into RuPaul's Drag Race at the moment. So I have at least like 40 minutes of sitting on the couch. And if anyone wants to ask me any questions, you're super, super welcome to ask. So thanks so much. Listen.